x square or you will remove y square, and then we will find the answer of the second variable, that it will be y. For example, from this equation, if you want to remove x only in first go, so what you should do, that you should multiply equation number 1 with the coefficient of x square, that it is will be 2, and 7x square is a coefficient of first equation, so you should multiply the whole equation, left hand side and right hand side with left hand side and right hand side with the constants. So once you will start it, it will become 14x square minus 6y square, 4 2s are 8, 7 2s are 14x square plus 7 5s are 35y square equals to 7 7s are 49. So once you will multiply it, you have made the coefficient same. So this is 14x square and 14x square, so both will be cancelled. So we have subtracted two equations, multiplied with coefficients of 2's coefficient with first equation, and the coefficient of 7 of x square of first equation is multiplied with the second equation. So purpose is this, we can make the coefficient of x square same, and then we will subtract and we will cancel it out. So 35 and 6 will become minus 41 y square, and minus 49 plus 8 will again become minus 41. So y square will be equals to minus 41 divided by minus 41, that is y square is equals to 1. And once you will take the square root on both sides, so whenever you apply the square root, you will be getting plus minus 1. So y value will become plus 1 and minus 1, and we write two values collectively in this pattern, y is equals to plus 1 and minus 1. Now once you have gotten values of y, so what will you do, that you can choose either equation number 1 or equation number 2. For example, for y is equals to 1 and y is equals to minus 1. So if you choose the first equation, let's suppose this is 7x square minus 3y square equals to 4. If you substitute the value of y right here, it will become, that is 7x square minus 3 equals to 4. And this will become 4 plus 3, that is 7. So 7x square, and x square will be equals to 7 divided by 7, that is equals to 1. So value of x is equals to plus minus 1. So as I told you yesterday, that once you will get the values of x and y, so you have to make the pairs. So how will you form the pair? Please look at, actually there are the two values, x equals to 1 and x equals to minus 1. So if you will make the order pairs to write it into the solution set, you should write it like this one. If x equals to 1, its corresponding value of y is 1. So you will write it first pair as 1 1, second pair will be minus 1 comma 1, like this one. Similarly, for y is equals to minus 1, once you will substitute it into equation number 1, suppose, so again you will be getting same sort of value, 7x square minus 3, and once you will substitute the value of y, that is minus 1, because it is a perfect square, so it will generate minus 1 whole square, again it will become positive, and plus into minus 3 will generate minus 3. So it will become equals to 4. So 4 plus 3, that is equals to 7. And again you will be getting same answer, that is 7 by 7, that is equals to 1. So x square will be equals to 1. And same x will be plus minus 1. But right here again, if you separately write the values of x, x equals to 1, x equals to minus 1, and corresponding to these two values, if you pair up such values, x equals to 1, then corresponding value of y is minus 1. So you will pair up like this one. And minus 1 for x equals to -1, y is again equals to -1. So you have gotten 4 pairs in this part. 4 values of x are the solution of this equation. So you can write it in 2 ways. First one is this, that you simply put all these pairs into solution set in the form of order pairs: 1 comma 1, -1 comma 1, 1 comma -1, and -1 comma -1. And there is another way that you can write the terms in this way. That is, if you collectively write it as, because there are the 4 values, you can collectively write as +-1 and +-1 in this form. So this is how to decide that you can write it as. If you look at the values in the order pairs, x is positive in 2 order pairs and x is negative in 2 order pairs. So if you want to collectively write it as, so you can write the values of x are +-1, and against each value of x, y's are also in the similar way. Against positive value of x, there is a positive value of y, and against positive value of x, there is a negative value of y. So that's why you can write all these 4 order pairs in a collective format like this one. So this will give you the solution set. Either you can write it in this format or you can write it in this format. Both are considered to be the correct one. So this is how you will write the solution set. It is a question number 9. Start working like this one, that you will factorize this given expression, that is x square plus 4xy minus 5y square, that is equals to 0. So if you pair up these two terms, we will do the midterm breaking. So actually you need to find the factors of 5x square and y square. Right? We are going to work it out through midterm breaking. So midterm breaking will generate 2 factors. X square 4xy should be the midterm, fine. So we are making the factors of -5. So I would write 5xy minus 1xy as midterm breaking, like this one. So you need to find 2 factors of -5. So -5 factors will be suitable, 5 times -1. And we will place x square, x and y with both 5 and -1. So once the midterm breaking is done, so we will take common from first 2 terms and last 2 terms. So you will see that x is common. So it will become x plus 5y. If we take -1 common, -1y common, it will become x plus 5y. That is equals to 0. X plus 5y, x minus y equals to 0. So these are the 2 linear equations. And identification of linear equation is this, that there will be power 1 on both the variables x and y. So it will become a linear equation. So put it separately, like x plus 5y will be equals to written as 0 as first equation, or better to rename it. At for example, let's put it as a third equation, and x minus y is equals to 0 for this factor. Rename it as equation number 4. So as I told you earlier, that we will first generate 2 linear factors or 2 linear equations from this compound quadratic equation. You can see that from equation number 2, we have generated 2 linear factors or 2 linear equations. You will put them separately, and then we will solve this equation number 3 with equation number 1. This above quadratic equation, that is equation number 1. We will solve actually equation number 3 and equation number 1, and we will find values of x and y. Same will be done, that we will solve equation 4 and equation number 1 simultaneously, and we will find 2 values of x and y from this pair. So we will be working one separately, like first of all, from third equation we will do this calculation, that find x in terms of y, that is x equals to -5y. And we will put it in equation number 1. And what is equation number 1? So let me first write it because it is written right on the top of the page. So I will rewrite it for you so that you can see it. X square plus 2y square equals to 3. So substitute where there is x minus 5y whole square plus 2y square equals to 3. That is 25y square plus 2y square equals to 3. So it will become 27y square equals to 3. And y square will become 3 by 27. Cancellation will generate 1 by 9. And y will become plus minus 1 by 3 because you will take the square root, so you will be getting two values of y. So in the very similar way, we will solve equation number 4 and equation number 1. So how to solve? From equation number 4, you will derive the value that is x equals to y, and you will put it in equation number 1. So what is equation number 1? It's better if you rename some equation number because we will utilize it. Like for example, this was 4. So rename it like, for example, equation number 5. We will use it later on for finding values of x. And on the parallel to this, for example, you can name any, like for example, this is equation number 6. So we will substitute x equals to y in equation number 1. So what is equation number 1? As I have written on left hand side, you can see same equation number 1 will be written again. And you will substitute the value. Where there is x, you will substitute y. So it will become y square. We are substituting value of x, that is x equals to y in this equation. So consequently, the whole equation will be transformed in the form of quadratic equation of y. That is 3y square is equals to 3. And y square will become 3 by 3. That is y square will become 1. And y will become plus minus 1 because we are taking under root for finding values of y only, as we have done in the previous part. So we have actually calculated two values of y as well from this combination and from this combination. Now again, we will use the above equation number 5. For example, if you will go into equation number 5, that is x equals to y. So you can see that if you substitute y as two values, plus minus 1, so consequently you will be getting two values of x as well. So a collective pair will become plus minus 1, first values of x, and then values of y, as we have done the calculation right here. So this will be the second order pair, and in the similar way, if we will find substitute value of y in equation number 6, this value of y, that is x equals to minus 5y, then this is minus 5, and you substitute values of y, that is plus. So minus 5 by 3, and this my negative sign will change the signs of inside, that it will become again plus minus 1. So this will generate values of x. And for this part only, I will write the pair right here. X is plus minus 5 by 3, and its corresponding y's values is plus minus 1 by 3. So we will write these pairs into the solution set for writing the complete solution set of this equation. So the point is this, that this is a part of the solution set, and it is also the part of the solution set. So if you write it collectively, the space is quite less. I want to finish the question on the same page. So I want to write it in the solution set exactly here. So we can write it as plus minus 1 for first pair, this one, and the second one, that is plus minus 5 by 3 and plus minus 1 by 3. So this will finish the question or the solution set.